This is a production of Cornell University.
Okay, we'll get started. Well, thank you very much again to the Cornell Seed Conference Committee and to you, Alan, for inviting me to speak today. I'm very proud and privileged to do this. I'm very passionate about this particular topic and have had the great fortune of being able to immerse myself from a both science and technical perspective in this area of seed technology. And I hope to share a little bit with that today with you. My contact information, I'm sure this will be shared down the road with anybody with the information from the presentation, but feel free to reach out at any particular time with any additional thoughts or questions that come up from this presentation, or just a, hey, what if type question. We get them all the time, and we like to make sure that I certainly can point in the right direction of what may be helpful for individuals with questions around seed technology. So to give you an overview of what I'd like to cover today, and it's a broad topic, and I know we have a broad audience attending the conference today, and I'm hoping to focus on getting a common ground baseline of what the coating world is all about and what these look like, from vegetables all the way to broadacre crops. And I hope that is very clear, and the areas around these technologies that are available to all of us. And then we're going to spend some time talking about the key features of coated seed. And I use the word coated to represent the full range of seed technologies that are applied to seed. And we'll expand on that a little deeper. We'll then go into the types of coatings used today. We'll talk about those features that are involved, the equipment that's used for these coatings. We'll talk about that. And then finally get into the heart of the matter of seed treatment challenges and issues and solutions around some of these particular scenarios that take place out in the real world. So to set the stage, in your morning session, you would have heard from Alan, and Alan would have spent quite a bit of time talking about processing and the implications and selections and various complexities around processing. We're going to spend our time today speaking around this green shaded area, which is the treatment or selection of multiple of various options and inputs that companies can put onto seed. And in particular, we're going to focus in one area around coating and film coating, coating in general, the whole world of pelleting, encrusting, and film coating, or seed treatment in particular. There are a number of areas that get involved in this treatment sphere, from enhancing, priming, steeping, pre-germination, depends on what type of seed you're working with in these areas, upgrading in particular. We're not going to spend time about that. Certainly there are other inputs that are into the treatment world that we will be talking about, which are the traditional fungicides, insecticides, other products that are applied to seed. Those are quite important for us to discuss and understand that they're being applied to seed in a certain way. But along the way, we're very concerned about quality, and you'll hear this theme of quality throughout the conversation today and the presentation as to a major concern that we will have and talk about as we go forward. So to set the stage, the family of coatings, and I thought a descriptive and pictorial description of these families are quite helpful. This is onion seed that has been film coated with a seed treatment. On the left here, the blue that you see. And then in the middle is the black onion seed itself. And on the left is a mini pellet or encrusting, white colored, and the green on the right, which is also mini pellet encrusted version of a coating on that seed. And then finally, we get into pelleting of that particular seed. And here you have the full range of seed technology for a species, in this case, onion, ranging from film coating through mini pelleting or encrusting, up to a full pellet. Now, not every seed crop is utilizing these technologies in the full gamut. Vegetables tend to be more utilized in this area. Broadacre crops, corn, soybean, traditionally tend to be just in the film coating seed treatment area of the family of products. This gives you a broad view of the opportunities of applying seed technology to seed from a coating perspective. And within these coatings, additions of value can be added, particular seed treatment, and other beneficials can be added to these coatings that you want to put onto seed. So what are the advantages? Why do we do this? Well, seed handling is a very major input on this area of seed coatings. We're taking something that could be irregular size and shape and make it uniform. We might want to take small seed and build it up in size to make it more marketable. Growers are able to plant coated seed in various machinery much easier. Coatings improve flowability, both in the actual seed plant and in the planter box itself the growers use. And we can increase the seed by weight to improve air seeding by plane. And then we also have a health and safety factor around coated seed that it's around worker safety. Handling of the seed itself is quite important in making sure that what we put on seed stays on seed and doesn't get airborne. Cultural practices, very large for certainly the vegetable industry around coatings. Without a lot of coatings that go onto seed, it wouldn't be possible to plant as uniformly in these fields, namely vegetables, direct seeded crops in particular. Lettuce comes to mind immediately. Sugar beet, of course, is another one that's used quite heavily, and we'll talk about that crop a bit further. But by space planting, we're able to take care of the normal agronomic conveniences that we all like to talk about. In other words, competition, moisture, nutrients, sunlight, availability for the plants to compete in a normal environment, less stress overall. And when you have less stress, you tend to get better plants. Better plants tend to lead to be better yields. And then finally, with the planting perspective, we get a prescriptive seed treatment. So we're starting to see prescriptive seed treatments come into play by region. In other words, if we have hot spots for nematodes, we can apply nematicides onto seed, and we can have an impact in a regional area that may not be so such the case in other areas or parts of the geographic planting territory that's going to be used the same crop. So it really becomes prescriptive, and we're seeing more and more of this as we move forward in seed technology. And we really like what we're seeing here from the application of treatments onto seed as a prescriptive element. Where companies and particular professionals like to get involved with advantages of coatings on seed, and the benefits, one of them that comes immediately to mind is branding. Being able to brand a color or a look or some sort of effect around that seed that identifies the end user with that treatment or with that application on seed. And we do see quite a bit of this. People like colors, they like the way it looks in the bag, they like the way the seed appears. It provides a lot of perspective from the end user and perceptions of quality. There's also an opportunity to do bolt-on applications with these value additions. So you might have a seed treatment platform, then you can have a biological platform, and all these can be bolted onto the seed at various levels within the particular coating application. And this is becoming more and more popular as you have these different opportunities to provide these bolt-ons. And that leads into the differentiation by region, allows us to do that very flexible from the perception of having end users do that. There might be a downstream co-op that's doing seed treatment, and they can be very flexible about what they're putting on seed based upon the region and the differentiation they're trying to do. The other benefit is companies taking non-saleable seed. Let's say they have a seed lot that's too small and they want to make it a little larger to make it saleable so it plants better for the end user. That's where you might employ some encrusting technology to be able to build that seed up and provide the benefit of that particular coating or treatment on seeds. Of course, future editions, we've talked about that. It allows the platform to put those onto seed with these coatings, and then it's a quality platform for the end user. It just gives the right look and right feel of what we're trying to do. And all these built-in benefits that provided by coated seed really do add up in the end for the end user. When we start to move into quality, and this is probably one of the largest areas within this subject matter that we could spend a lot of time talking about each of these areas. And really they fall into These major categories: dust off, flowability, plantability, seed safety, buildup, and appearance. We'll start off with dust off. Dust off is a major concern. Whatever we put onto seed, we want to ensure that that is staying on the seed. We don't want that being airborne during the planting process, or from a perception of having materials in the air when seed is being treated at the actual seed plant for worker safety. We want these products to stay on seed. There is technology to allow us to test using a Hoybach dust meter. This is a European machine that measures the amount of dust coming off seed in a controlled test. The European Seed Union have employed this technology to guide them in a guidance of what seed must meet in terms of a minimum level of dust off. In the North American market, we haven't quite got there with a minimum required dust off level, but we do tend to follow the European lead with their standards that they have put forth. This Hoybach dust meter, not everybody has one. There are a number of third-party laboratories out in the industry that does. SGS immediately comes to mind. They offer dust off testing services, and you can send a seed in or have it tested, and they will certainly do that. Many of the large companies will have these in their laboratories for testing products as a very common quality control parameter. Flowability. Flowability is really measuring in two aspects. We can have wet flow and dry flow. Wet flow is coming straight out of the treater, no curing, no drying, nothing, just simply the product leaving the treater, and we measure flowability. That's probably the worst case scenario of how the seed will perform downstream. And then we get into a dry flowability where the seed has been allowed to cure. It's either 24 hours after treatment, it's in the bag. We're going to take a sample and measure flowability. And there is technology to measure flowability. You'll see a picture in a little bit of what that is. That falls into plantability. Plantability can be done using a planter test stand. There are a number of companies that have these for third-party testing, and also many companies have them themselves. Again, testing the plantability of the coated seed to ensure that we aren't causing any problems with the planting function of that particular seed species and the coating within it. Seed safety, the number one thing is do no harm. Whatever we put on seed, no matter what it is, from a film coat all the way up to a pellet, we must do no harm to the seed. And in the early days of coatings, there were times where harm was had. And I can tell you from firsthand experiences that those are not fun to deal with, in particular when you have issues in the field based upon a coating that did not perform as it should have. But we've learned over the years of what best practice, application, technology, materials, all this experience has really come into play where seed safety are basic table stakes. They just are there as part of what's expected. That seed is expected to perform. It's expected to germinate in a wide range of environmental conditions, and it should also be able to withstand storage over time and have no harm done to it as well with any type of coating on it. Now, there are some limitations. When you do some special enhancing, like priming, for instance, priming will, over time, the lifespan or storage of that seed will diminish over time. It's not to say these things are bulletproof, but we do need to be ensured that we're keeping up with storage as a commercial saleable product for the marketplace and that we're doing no harm in that area. The next item is buildup. This is buildup of coating material on equipment. Basically, it's sticking and leaving a residue, and that buildup occurs over the course of the treatment cycle, whether that's all day long or for an hour or for weeks if you're not cleaning down. And this can be a real troublesome problem. This buildup can be really an issue downstream. We can get flakes of coating coming off during the transfer of seed from one location to another. And these buildup flakes or coating chunks can ultimately end up in the bag or the box or whatever packaging material we're using. And that ultimately ends up in the planter. And that causes major issues for growers. You've got plugging of various planter equipment, and we get skips or we get problems, and it just is a headache for everybody. And we just want to avoid those. And there are some things we can prescriptively do to avoid buildup. And then finally, least but not nearly a bottom feeder here, this is appearance. Appearance is really a quality effect. And in the old days, we were simply coloring seed and trying to get some effort of color on there to meet the Federal Seed Act for seed treatment. But nowadays, appearances, we can make these seeds look so glossy and flashy and really have a wonderful look to them. They almost look like pearls or candy-coated materials that we would enjoy. This appearance area has really come a long, long ways, and there's a number of elements that can go into appearance to try and spruce things up and give a good look from that perspective. So quality, these are the key items that we commonly focus in on, these 6 main topics. So dust off, to give you some perspective of dust off and to try and put some numbers in perspective, we traditionally measure dust off in grams of dust per 100,000 seeds. The EU has a level of 0.75 grams per 100,000. Those are very small numbers and certainly hard to understand if you're not looking at them in comparison to something. When you look at actives alone, they traditionally, if you're just putting an active on with no polymer, that those actives will have a higher dust off score than a seed treated with a polymer in a traditional film coat. And that's not to say all polymers are the same. Here you can see that we've got 2 different polymers and 2 different dust results from those particular polymers. And the reason this occurs is polymers have what we call a binding capacity, and that binding capacity is related to how much it can hold onto the seed when it is cured and fully dried. Film coats, as we'll talk a little bit later, create a fishnet on the seed, binding on products onto that particular seed, and we can overstretch that and go too far, and they just simply won't have the capability to hold on to those products beyond its binding capacity. In this case, you're seeing that effect here between what we call polymer A and polymer B with the same active loading amount on the seed. This is flowability. The flow meter you see on the right there is a traditional flow meter. You can load in a kilo of seed, set the gate to open for X number of minutes or seconds or whatever you wish to measure, and the gate will pop open. You can measure the flow, and you can examine what happens after that particular point of time. In this case, this is wheat looking at flowability in minutes, and obviously we want a lower number if we possibly can, and coatings can help in the flowability and improving the flowability over just actives by themselves. And this isn't to say actives are not doing a good job. They're doing what they're supposed to do, but many times actives, when they are dried on seeds, they can create a little bit of a grit, and that grit can cause some resistance and flowability. When you put a coating on, it can smooth that surface of the seed and get that flow moving a little quicker. Raw seed itself, or naked seed, that usually flows the best, and that is usually the sort of the gold standard of measuring flow is the actual raw seed itself. So flowability, easy to test. There is technology out there and equipment to use to measure flowability, and you can get a very good sense of how these particular products can perform from both a wet perspective and a dry perspective. So wet seed flow right out of the treater, we can put it in the flow meter and measure it, and you can wait 24 hours, measure the same seed, and look at the difference, and you will see differences in those wet and dry flows. Plantability. Plantability, this is from a planter test stand, looking at singulation. You can look at skips, doubles, placement. There's a number of things you can do across a variety of seed sizes and seed plates. This is corn and using a John Deere system, and we're looking for very consistent singulation across all seed types in this particular planter stand, and we're achieving that here. You can get a lot of great readouts from plant monitors that are out there in the industry, and a number of companies have them for their quality assurance testing. But again, something we want to look at as we're looking at coated seed to make sure we're not impacting these areas of plantability. We want to obviously do no additional problems in the plantability of a coated seed hitting the planter itself. Seed safety, germination. This is something that we all are very concerned about from day one with any coating on seed. We want to always be looking at the untreated seed against the actives and then against the coatings that may be going on. And we do this at time 0. We might spread this out at time 3 months, 6 months, 12 months, 18 months, 2 years. And some of those tests take actually 2 years to run. So we've got this real-time environment of seed being stored and running these tests to make sure we do no harm. In this case, you're getting a snapshot here in this graph of just a period of time, looking at the untreated, the actives, an actives plus a polymer, and then an actives plus another polymer in the light blue. You're really looking at the green and the light blue effects of the coating and what happens. And here you're looking at a warm germ result, a cold germ result, and an accelerated aging result. 3 common tests that might be run for corn in particular, maybe other crops, but these will be run over a period of time to ensure that we aren't doing any harm to the seed itself during that storage period of time. And it's quite important that we have all the controls in place to be able to measure these and do them in a proper way from a seed safety perspective. So very, very important. Can't underestimate the effect of seed safety. So now we've gone through quality. We've looked at the family of coated products. We want to take a look at what's really in front of us in terms of industries. And if we look at the 2 basic industries, we're talking about broadacre crops. That's the group up here on the left, and vegetables in the right. And there's some in between. We're all expecting the various performance levels of quality within these crops, but there are some very different expectations and very different scenarios in real world with these crops. Within the vegetable industry, there's small batches. When I say small and relative to what broadacre crops may experience. And traditionally, seed value at the vegetable industry has been much higher in terms of per pound. So a pound of tomato seed versus a pound of corn seed, 2 different complete dichotomy areas. Within that, the vegetable industry has had some very sophisticated equipment for handling these small batches, from coatings to upgrading to doing very specialized processes to that seed to allow things to occur. And in particular, in the seed treatment, seed coating area, there's been a lot of advances of these areas and handling seed, ensuring that the seed is treated with the ultimate idea of quality, measuring moisture and humidity and processes after that coating process to ensure that the seed is in its premier condition. The opposite of that is the broadacre crop sector. There we've had to, because of the large volume of seed that we're dealing with, there we've had to employ very large capacity seed coating, seed treating applications. And in many instances, there's just no way around it because we have to get that amount of seed through the system in order to meet demands and the quantity of seed that's required. So we have in this area, within this space of broadacre crops, we do have some very good seed treatment technology, very high level, but a little lower level on the actual equipment side. When you reverse that to the vegetable side, you have a very high level of equipment, but a very low level of seed treatment sophistication in terms of the products available for the vegetable industry. And that just goes to the size of the markets and where the value is placed in terms of acres and the expenditure within the large agrochemical companies and what products they're bringing to the marketplace. So it's not a surprise to anybody, but there are these 2 distinct differences in terms of how these crops are handled and what equipment is used within each sector. There's a little bit of bleeding occurring today of one into the other, and we're starting to see more of the vegetable side mentality entering into the broadacre crop side, and that's very welcomed. And you'll see why that's occurring when we start talking about issues and solutions. People have learned how to handle various applications in the vegetable side, and that's now starting to creep over into the broadacre crop. So it's quite interesting, but I thought this gives a pretty good perspective of what we're up against. To really break down these coatings, and we'll focus on this one in particular, film coating. This is onion, and the center picture here, you can see that we have the onion seed itself and a red layer of the seed treatment and the blue layer of the color. And these can be layered on if we have the ability to use multiple pumps, or they could be all slurried on at one time. It really is just dependent upon what technology the individual has for seed treatment. If you look at the various crops that are film coated, and here you're seeing some pictures of that pop up on your screen. You know, we've got some carrot and some tomato and various things like that. Brassica here on the left, and then we get into corn on the right. Film coating is used across almost all crops, and it does a great job of encapsulating the treatment onto seed. And the seed size is still recognizable. We can still see what the seed actually is. So film coating versus seed treating, today we incorporate a polymer into the slurry or into the application of the treatment going on seed. Dust off is the result of reduction, is the result of using that polymer. When we use a polymer, it's classified as a film coat. If we're not using a polymer, as we did many, many years ago, it was just seed treatment, and that was pretty much done in a cement mixer or some other type of rotating vessel, and we just threw in the treatment and whatever stuck, it stuck. But nowadays, with the advances of polymers and slurries and active ingredients, we can make a very nice package that goes on to seed, and we can apply it and with that polymer, and that will cure, and as I said before, a fishnet type effect around the seed, and allows it to hold the active ingredients on that seed. Within the vegetable industry, one big difference that is very important to recognize, and there is a drying step post film coating, or any type of coating for that matter on the vegetable side. That drying step has always been there in the industry because of the packaging requirements of managing humidity and moisture within those particular seed crops. For the Brassica crops, typically in the past, no drying has been done. There are instances where people are employing that technology now, and we'll talk about why that's happening, but it typically has not been done. But now we're starting to see more of that. So we wanted to make sure we pulled out that little nugget to ensure you understand that these differences occur within vegetable and Brassica crops. So we're seeing this shift of this technology. We talked about this high-level sophistication in vegetables, low-level treatment, and vice versa on the Brassica crops. And we're being demanded to do more and more. The Brassica crop sector is being asked to put more onto seed, and there is a limitation of geography space on the seed of what we can actually put on and not cause ourselves problems downstream at the treatment process. And those certainly can occur. As we move into the next sector and diving a little deeper in encrusting and pelleting, this has more traditionally been used in the vegetable and protected glass culture industries. And here we're looking for singulation. We want to be able to plant perfectly in the field or in the greenhouse. Every seed counts, and every seed has to grow. Every seed needs to be placed exactly where it needs to go. And traditionally, this has all been very much adapted by the vegetable or horticultural industry. Starting to bleed over a little bit into some Brassica crops with this encrusting technology, but in general, it's been focused in this area of the industries. Encrusting traditionally 10 to 30% buildup by weight, depending upon seed species. A drying step post encrusting is done because we're adding a lot of moisture to be able to build that seed up by weight. The seed shape remains visible. The edges are smooth. We can precise load on chemicals or other value-added products. Dust off is minimalized. We have seed handling, copper box flow advantages, and we have very attractive products. So encrusting offers a lot of opportunity for doing a number of different technologies on seed that pull us in a direction that allows us these values. Here you can see some drilling equipment, and the photo on the right shows an encrusted product on a seed wheel, a vacuum wheel. It just shows you the precision that we're going to get from this. That vacuum is going to pull up each individual seed. it's going to put it down in the ground exactly where we want it. And it avoids the whole issue of doubles and skips and whatnot done by this. So pelleting, as we finish up the last of the family of coatings, pelleting is the roundest of all products. It is the seed shape is unrecognizable, and the buildup by weight can go as much as 2 to 80 times, depending on the species. And that 80 is traditionally in small, very small seeded crops like tobacco or flowers, for instance. There are some very large buildups that take place. Sometimes there's a multiple of sizes of coating or pellets within a particular species. Sugar beet comes to mind. Depending on the size of the raw seed, there's been a movement of having a specific pellet type for each size of seed. And that's been employed in that particular market sector in areas. Within lettuce, there's opportunities for a couple of different industry sizes of lettuce seed as well from the coated pelleted side in that industry. A drying step is done here as well. We have to dry seed down. We have to take out that moisture. Want to make sure we get a good cure on that pelleting that's done. We want to ensure that we don't have any issues of the seed cracking or flaking or breaking off during that particular processes in the facility that's being done. We're able to load precisely chemicals onto pellets. And in fact, there is quite a bit of layering that goes on. We have the ability to load vast amounts of seed treatment onto these areas, these coatings, and we can move them out, the outside of the seed. And that allows some good advantages to target agronomic issues in the field by getting higher loads of seed treatments onto pellets. And it does make for a nice opportunity of layering them away from the seed. Some of them can be a little phytotoxic to seed, and by layering away, we can remove some of those negative effects from there. We can add nutrients and other additives to the coating materials to give benefits to the seed. Obviously, ease of planting is a stake there involved, and attractive products. Attractive products themselves allow for us to have a multiple of color schemes that can be used, matte versus shine. There's a number of different opportunities within the pelleting world that we can do to give ourselves some attractive looking products. So to give you a perspective of what these look like, and it's always nice to have some photos. This is sugar beet that you see there, and the blue pellets that have shown up on the right. Sugar beet was one of the first crops to be pelleted back in the 1940s. My former employer, Germinations, started that with a material supplier, and the whole movement was to try and get seed planting or space planting in the field to get the crop of the sugar beet to compete at a favorable ability. And so sugar beet is certainly one of the world's largest coated seeds from the pelleting perspective. Then you get into brassicas and carrots and celery, chicory, endive, leek, onion, pepper, of course, lettuce, I mentioned before, tobacco, flowers, tomato. They're all used in this coating area as well. Flowers, very, very small seed. Takes an extreme art and skill from the operator to coat these seeds, almost like flecks of pepper that are being coated, and they can singulate one seed in a pellet of these particular small seeded species in the flower range. Here's a range of raw and coated products from your left to your right. On your left, you have carrot. The next is fennel, and then onion, and lettuce, and tomato, and then a flower. I couldn't tell you what flower that is, but that's a flower seed. And it's quite interesting to see what these look like and how they migrate from the raw version to the pelleted version. We then also have the ability to do unique things within the pelleting range. Not saying this is employed across all crops, but certainly we're seeing this also more into the grass coatings that are taking place. Grass coatings are more of an encrusting, but they're starting to utilize some technologies to manipulate imbibition. And we have some hygroscopic agents for slowing imbibition, where we're vulnerable to water damage and cold wet conditions, so cold chill injury issues. And we can slow the water from imbibing into the seed quickly with certain coatings. And then we have hygroscopic coatings or wetting agents. And this is to speed the water uptake or create some sort of a gel around the seed. And this is where the grass industry is starting to show some improvements in this area of having seeds attract the water and creating this sort of a gel. And I have some pictures here to show you. Down the bottom in this petri dish is a grass seed coated with a material that will form a gel when it gets wet. And that gel is water activated. And you can imagine in some arid locations where the water is not predictable, that this offers the opportunity for the seed to experience some water that it normally wouldn't have. And these hygroscopic or wetting agents do perform quite nicely. The other area is splitting coats. And split coat has been around as a trade name for a number of years from a company called Incotech. Back in the day, it was Royal Sluice. And the split coat allows for the cracking of the coat to open up and expose the seed to light. And there are some phenomena that take place with light-seeing requirement of seeds, namely lettuce, in order to germinate. It's a natural defense mechanism. If it doesn't see light, it won't germinate. In this case, we can employ the splitting technology of the coat to allow the light to get in, and it will overcome that photodormancy. You can see on the right how that split basically just cuts right in half of that seed type, and it really does do remarkably well. And there's a number of these products on the marketplace today that allow the splitting to take place. Rapid melting or sort of the disintegration of the coating. Very important for certain industries. I want to draw this out that there are these coatings available. A lot of flour, tobacco companies are utilizing this technology because they want the seed to release immediately out of this coating. As I click the mouse here, you're going to see what happens to the coating. You can see on the right the red pellets starting to disintegrate as they experience some water. And here they are completely disintegrated and completely gone within seconds. And it's quite amazing how these coatings work in this area and allow for us to prescribe this opportunity in agronomics for the seed to be exposed very quickly to the planting environment. So how do we get these materials on seed? And there's a number of pieces of equipment that are being utilized. I'm going to walk you through some older technology all the way up to what we use in a modern day seed treatment application. This is what we call a spouted bed. This is for film coating. How this works is we load a batch of seed in this vessel, and then we fluidize the seed by pushing dry air up through the bottom of this particular cone. And then we inject using a spray nozzle the seed treatment slurry, binders, and pigments. And the seed sort of tumbles and moves around in this cone. And the air is exhausted through the top and captured and abated. This type of equipment is very early day equipment for film coating. You can immediately see that the batch capacity would be limited, and that your capacity per hour would be quite slow. It does do an effective job. What it does so well is it dries during it coats, and so you can get some layering if you are so sophisticated with your setup. But it does provide a nice way of getting that seed treatment onto the seed using a spouted bed. The next piece of equipment that's utilized, and you still might find these today, is a side vented coating pan. And this is a technology taken straight out of the pharmaceutical industry. This is how tablets are made. And this again is a batch process. And there's a spray boom arm that you see, and I'll pull that up a little closer for you. This spray boom has multiple spray heads on it, where each individual spray head could be a different ingredient. And it allows for these materials to be sprayed onto the seed and controlled either all in one or one by themselves. great flexibility for application of materials onto seed. And the other unique thing about this is the drum rotates and the seed inside tumbles, but the drum itself is perforated, and we push drying air through the drum, and we can actually control the air in terms of the amount of humidity that's in that air with these systems. And it does a very effective job of drying the seed. This is batch to batch coating, so you have to load the seed in, do the treatment application, then unload the seed. And it can be fairly cumbersome to get a good amount of throughput through. But you still will find these in the industry. This equipment it can be and is expensive. Pulling from the pharmaceutical industry, you can imagine that might be a little bit more costly than some of today's seed-related equipment that's used for seed treatment. This next set of equipment, the film coating seed treatment, high volume continuous treaters, these are very common. You'll find a number of these out in the field at various levels within seed companies, downstream dealers, cooperatives. It just is a matter of where you look, you'll find these. These are rotating drums, typically have some sort of inlet on top that allows for the seed to go through in a controlled manner. It's pretty much free flow. You can throttle down the inlet a little bit, but it does open wide up and just move through. You have an atomizer that is atomizing the liquids onto the seed, and then the seed enters into the rotating drum, and that drum is turning, and that drum by turning allows the seed to rub up against each other, and by adhesion, cohesion, that treatment is pulled on and off each other, and by the time you're done getting through the bottom of that drum, you've basically coated the entire seed with a particular product. These are very common, come in different lengths and different inlet mechanisms. You can even add dry powder applicators to these units to apply powders to them if we're dealing with some issues of tack or wanting to improve the appearance or shine. Those powder feeders are employed these days in a number of applications. And we'll talk a little bit about some of the pros and cons about that as we go a little deeper in the presentation. But again, high volume continuous treaters here is what you're looking at. Many different model of these exist in the marketplace. For pelleting, it's really down to pan coating. That's where we were for a number of years and still used today. These pans really come from the confection industry, where we're coating like nuts or seeds with chocolates or any other type of material or seasonings that go onto seed. So pan coating has really been around for a number of years, and we've adapted it to seeds for pelleting technology. There's different sizes of pans. There's round ones, which we call ball mills, or cylinder types, or flat pans. There's a number of different geometric shapes of these pans, but they essentially do the same thing. They get the seed to cascade, and then the cascading effect, we're able to allow seeds to be coated by the operator. And this technology, more than any other from the pelleting perspective, requires a skilled individual, and that is an art form as much as it is a science. And these individuals that are doing this type of work are very skilled, very seasoned, and have a number of years of experience in doing this technology. You can automate this. There's been a number of companies that have done that, and the automation does work, but you have to have the right seed species, the right materials to do that. Very difficult to automate coating like tobacco or flowers, for instance. That really has to be done by skilled operators with the right materials. And finally, we end up with rotary coaters. Rotary coaters are batch treaters that we see today, very common. A lot of seed companies have these. We've got a spinning disc on the bottom that moves the seed centrifugally around the drum. And then we have an atomizer disc where the liquids are put onto. The benefits behind a rotary coating is that you can use this technology for encrusting and pelleting by adding powder feeders. And it allows for a lot of flexibility from film coating, seed treatment, all the way through encrusting and pelleting. The technology is widely adapted across a vast number of species. I wouldn't say you could pellet tobacco in here from starting from the raw seed. You might be able to pellet or finish tobacco seeds in here as they're pelleting through the process, but certain seed species obviously wouldn't be advisable to do. But certainly for a lot of vegetables, all the way up through variety crops, widely adaptable piece of equipment to use. Have a little video to show here from a graphical point of view. You can see the seed entering here in this demonstration, and we're injecting liquids, and then powders are being injected to coat onto the seed. And that's the basic premise of this takes place during a batch coater, is that we're able to control each of these inputs when we want them and for how long we want them to achieve the process. And by using batch coaters, it's relatively a fast process that's taking place in these drums because the seed is moving at such rapid pace. It is a very quick application in a number of areas. Again, high capacity output, continuous batch, so the batch drops in, we coat, we eject it, the next batch is already dropping in, and we just keep going until we run out of seed. Very highly effective products and technology in this area. There's a number of manufacturers that make these equipments in different sizes, from small lab size piece of equipment all the way up to full-size production units. Okay. Now we'll take a dive into seed treating issues with the last 10 or so minutes we have here to talk about some of the issues and some of the things that we're looking for when delivering quality. And we have a high pressure at all levels, no matter if you're in vegetables or variety crops, that we must deliver quality. And that quality starts with the seed treatment that's going on the seed. And that has to do with seed loading. In other words, what we put on the seed, we want to ensure we have two things, that we have bulk loading and seed-to-seed loading. And that all ties back to recovery. In other words, whatever we're going to put on in terms of the application rate of the seed treatment, we want to ensure that every single seed is getting what it needs from the exact dose rate. So we could treat a batch of seeds and we could have a sample of that seed and we could test it for its recovery or bulk loading. It could come back just fine. We just happened to sample the area that had the amount of product on the seed. If we took another sample of that batch where it did not get the correct amount of loading, our seed-to-seed loading would show that difference. So we want to ensure when we are treating seed that we have two things. Not only do we have seed-to-seed loading, but we also have bulk loading. So no matter what sample we take, we're ensuring that we are getting that recovery of product on seed. There are a number of laboratories that can do that testing, of recovery testing, and it's very, very common to do in today's world from all different sectors within the agronomic markets of seed treatments. The demand for better looking seed, that is not stopped. That is continuing to push the envelope. We've got these perfectly looking pearlescent seeds nowadays, and that just equates to quality in people's minds, and that's a very high level of requirement, and we can get ourselves in trouble very quickly by trying to achieve some of those looks if we aren't careful. And some of those can be disastrous, and some of them can be very successful. But those disastrous ones are mainly due to coverage issues. And within the slurries that we're utilizing, non-compatible products that fight against each other, that we don't seem to get the appropriate look we're looking for. And that occurs very many times, and that we tend not to do our due diligence when working with coatings and recipes and doing our testing to ensure that that is not the case. The introduction of insecticides, nematicides, biologicals, or biostimulants, they all have an impact on appearance. Each product has its own special formulation. Each product has its own amount of ingredients, whether it be active or inerts, and they can help or detract from the appearance of the final product that is being produced from the particular seed treatment plant. And it's really again down to testing that recipe and making sure that what we do is providing the appropriate look, and that's starting in the lab and then scaling it up and then getting to production with it as we move forward. And we've mentioned many, many times about the barley crop challenge of how much can be loaded onto seed. And that's an issue because once we go too far, we become too wet and we create all sorts of issues for us downstream that relate not only to buildup, but appearance issues. And we have flow issues that occur as well with this challenge of getting too much on seed. For vegetables, we've got that drying step in there, so it really doesn't become too much of an issue. We can overdo it, of course, in the treating equipment, but with that drying step, we tend to alleviate most of those problems. With barley crops, we just don't have that, and so that's something that we really want to make sure we're looking at. Here's a great example on the right-hand side. This is looking down the barrel of a seed treatment, a continuous treater, and you can see the chunks of material that were pulled out. And that's over a period of time that this built up. And this buildup was the cause of tack or cure time, lack of, and over-treating. And it ultimately resolved itself as being a calibration issue with pumps that was having too much material applied during the seed treatment process. These flakes were flaking off, not this big a size, but smaller versions of this, and getting into the downstream product and into the bag product going down to the grower. Big issue, big problem, and we'll talk a little bit about how to kind of cure that. So buildup caused by tack, cure, flakes, recoveries, all those issues are around buildup. Appearance, when we start having too much liquid or too much product going on, we create these things called moon craters or golf ball dimples. That's a relation issue to coverage, which flows over into the flowability, whether it be wet or dry, and plantability. So everything relates back to ensuring that our recipe is dialed in for our treatment that we're going to do or coating that we are going to do. We don't want to accentuate any problems downstream because they multiply and they become large like you see here in the buildup. So to tackle buildup and tack, we talked about drying, and that drying can be imparted in a number of ways. It can be done with an actual dryer. It can be air time or some sort of curing time. A lot of facilities on barley crops just have a very small footprint. They can't put in a lot of equipment around their seed treater. We want to have no restrictions on capacity issues. We want to be energy efficient and be simple. And there's some new technologies that we can impart in today's world to try and incorporate some airtime, some drying around this. In these photos you see here, there's 3 different strategies being employed in the various opportunities. What you see on the left is a rotary fluid bed dryer, not the big blue item, but the one on the left, the gray item. The gray unit is a rotary drum that has air being going through it. The seed rotates through it and moves through at a very rapid pace. And that rotary fluidization is very effective of curing or drying the seed and creating not the buildup issues that we can get downstream. Drying belts are another avenue of utilizing drying technology to eliminate buildup and issues of such. Fluidized bed dryers, again, another opportunity to utilize. So there's a number of technologies now coming through into the barley space that allow us to attack some of these issues that we have. A lot of times we've tried to solve them with powders or drying powders. And those are, while good to achieve maybe the initial effect, the long range effect of that may not be so good. And from that perspective, if you've been in a facility that's using dry powders as part of the treatment process, they do become airborne. They get on equipment, the floor becomes slick, people can slip themselves. There's dust issues. There's just a whole host of things that can happen with powders that go on seed as a drying aid, and something that we want to consider maybe trying to abate if we can by using technology. I realize we can't all do that given the certain footprints that we have, but there are avenues that are coming out and other potential mechanisms to deal with that. Airtime, probably the biggest thing that we can give ourselves when we're treating is airtime. And This is a very common box-to-box seed treater. This is a very rapid seed treatment application. You put a pro box of raw seed on top of this unit, flip it on. The liquids are injected through the atomizer as the seed is passing through the auger. The auger then moves the treated seed into the next box. So in this scenario, you can see that there's very little airtime. And if you try to impart too much seed treatment and you have conditions of temperature and humidity that don't line up, you could end up with a pro box of treated seed that is very rigid and would need some encouragement to flow out the bottom of the box. So it's, again, airtime is real important. And sometimes we don't have that luxury. Other times we do. But in this case, just to show you graphically from a photo, here you can imagine very limited airtime, just that 9 or 10 foot length space of the auger, which actually there's a lot of seed treatment happening in that auger as the seed is pushed up toward the discharge point. So some adjustments to consider if you're faced with issues and sort of the toolbox you might employ to try and deal with some of the issues of appearance. And polymer is one of them. There are polymers today that have very good shine elements to them and can also be matte. It just depends what you're looking for. But from the perspective of a polymer, this is where I would look to try and improve appearance. This is one of the avenues that would be first in the toolbox to pick up for appearance. The amount of water that's used in the slurry, this is something that we commonly get asked or are questioned about when people are having trouble with coverage. And a lot of times by just reducing a little bit of water in the overall slurry package, we can improve the coverage by concentrating the actual liquids going on seed. And it can be reversed too. We can need a little bit more water to help with coverage. But traditionally, it's taking a little bit of water out. That tends to help coverage when we're looking at appearance from a slurry perspective. The atomizer and the equipment. The atomizer does have an impact. Many people using certain types of atomizers for liquids have a basket or some sort of webbing on that atomizer to help sling the liquids off the atomizer onto the seed mass passing by. We tend to find that a disc atomizer gives us a better application onto seed due to the fact that it's just a fact of life. We don't clean the atomizer probably as much as we ought to. And the basket types over time, we tend to clog the holes in the basket and we don't get a good movement of liquids off that basket into the seed mass because there's holes are plugged. Using a flat disc with a slight edge to it allows us to have immediate success of getting liquids onto seed and very minimal issues on cleaning. Finishing powders, mentioned them earlier. Finishing powders themselves can aid in appearance. There's the downfall that finishing powders may not stick to the finished product and may become airborne or become a dust-off issue. So I would cautiously look at this as an area of potential improvement for appearance, but they do work effectively. And if they're incorporated the right way with the right binding capacity of the particular polymer, we can achieve wonderful things. And then finally, the actual color itself. The color, there's many color manufacturers out there in the industry, and there are differences in color. And that just needs to be tested and evaluated in your recipes that you're doing. If we're having dust-off issues, I would go straight to the polymer, look at that. Of course, look at the water and the amount of slurry that's being used, but the polymer is going to be the tool that I'd be looking to here for dust-off, and making sure that we have the appropriate binding capacity of that polymer to ensure that we are holding on those seed treatment items onto seed. Pack flowability and bridging, that all boils down to an equipment, polymer, and finishing powder area. And this area is where the toolbox exists for you to take a look at in terms of areas within the facility and where improvements can be made from the equipment side, maybe drying, from the polymer side, using a polymer that reduces the amount of finishing powder, or a polymer that improves flowability, a polymer that cures faster, that reduces that tack time, that improves flowability and lessens bridging. And of course, if you're using a finishing powder, making sure you're getting the right amount on, not overdoing it, and considering all the issues around that as well. And then finally, seed safety. If we have issues around seed safety, it's all around testing, making sure that we're doing the appropriate tests in the appropriate lab manner to ensure that what we're putting on is done in advance of tests, so that we can be assured that when we hit the facility and the seed processing plant that we are doing no harm to the seed. So these are some of the tools that I'd pull out when looking at a problem and employing multiple strategies. And it takes multiple strategies to overcome problems in the facilities that we're working with. And with that, I think we're just about on time for you, Alan.
Peter, this is perfect. Thank you so much for your great presentation and overview of all these modern seed technologies, seed coating technologies, and seed treatment technologies. I want to open it up. Please, if you have a question, just unmute and ask, or you could use the chat and type in your question there. Can you go to the last slide for that CCA? There we go. Yep. So again, those of you that want the CCA credits, that is the information for you on the CCA credits for Peter's talk. But again, I want you to make sure if any questions, get a lot of information to assimilate and things like that, to process before they may be able to even ask a question. I know I was taking notes as we're talking as well.
Big subject matter, I know.
I'd like to just congratulate Peter on a great presentation. It's always interesting. I see a lot of these topics, but from our standpoint, a little bit more from the field crops or the broadacre crops, as you're referring to them, whereas Peter's coming some from the vegetable side. So it's always interesting to see the differences in the issue. I always say that I tend to look at the vegetable crops, other specialty seeds, to find out what's coming next, what's going to hit us. The fluidized bed dryers are showing up. Sometimes the one surprising thing is I see them often in soybean, maybe more than corn. Certainly in cottonseed, where they've got real high application rates, but the soybeans don't tend to soak up the water as well. They just don't really like water that much, and so sometimes you see things used that you wouldn't expect would ever perhaps be economically viable. But if there's enough volume involved and it can solve problems, sometimes, you know, it's like getting a big hammer to make sure the problem's taken care of. But I am seeing some of the same trends that you're showing in there. So,
thank you, Alan.
Any other questions?
Yeah, this is Bob King. And we keep hearing a lot about how the weather and the climatic change and all that's have an impact, or potentially could have an impact. What type of impact could you see on these technologies?
That's a great question. That is a real factor. So if you can imagine soybeans being stored in silos outdoors under very cold conditions, and moving them into the seed treatment process, there is an adjustment that's made for that during the seed treatment process to ensure that that recipe is appropriate. We see later in the season, when the beans warm up and they enter the seed treatment process, that whole recipe changes. And the curing or the tacking that occurs, that dynamic moves dramatically from that warming of the seed. And so as our conditions change over the treating season, we do see a difference of recipe adjustments have to make them. And it's just, with climate change and what's occurring, we see more swings throughout that season than we have ever before. And so I think we're going to have to employ different strategies throughout the season in order to overcome those obstacles that we see from the environment. In controlled environments like a vegetable processing facility, where we're dealing with seed in small lots that are more environmentally controlled, we really don't see those issues. But with broadacre crops, we're storing vast amounts of seeds in basically environmental conditions that are different, in almost ambient in cases. We are experiencing those differences. So it has to be employ a different strategy throughout the year for that.
Thank you.
Okay.
Peter, this is Mike Migliazzo. Would you foresee an opportunity for in the polymer industry to tailor properties for polymers that have different film forming characteristics for these weather, to address some of the weather conditions that seeds are being treated in, anytime between, like some people treat in December, some treat in May?
Yeah, that's exactly right, Mike. And thanks for the question. And we do see that, and we are seeing some asks around binding capacity to adjust that binding capacity to match the environmental condition. The problem is we can't predict it, and we could run ourselves into a little bit of an issue, one way or the other, on that knife edge of an area. But there are small tweaks we can do within that polymer space to allow us tweaks of the binding capacity of the same product to give the same look, but to change the overall dynamics of the rheology of the product.
This has been a production of Cornell University, on the web at cornell.edu.